All right, 7.6 is called quadratic equations. So before we were dealing with just expressions, meaning we had no equal sign. So now we're going to throw an equal sign in there and then solve them. That makes them an equation. All right, so let's go ahead and start with a factored equation. So let's just say we had some quadratic and we already factored it, and we got the quantity of x plus 1, x times x minus 4 equals 0. All right, so what we're using here, I'm sure you've seen this from algebra, we're using the zero product property. Zero product property. And all this says is if we multiply anything times 0, then we're going to get 0. So notice that we have a term here times another term. When you multiply them, they have to equal 0. So that means one of these has to be 0. So the way we do this is we set each one equal to 0. If x plus 1 is 0, then everything will be 0. If x minus 4 is 0, then everything will be 0. And then we solve those algebraically, subtracting 1 from both sides. We'll get if x is negative 1, or if x is 4, that means the entire equation will be 0. You could always plug them back in to check. Plugging in, notice that if I plugged in negative 1 for my x, I'll get negative 1 plus 1 times negative 1 minus 4. And this gives me 0. This one right here gives me negative 5. But it doesn't matter what this binomial gives me because anything times 0 is going to be 0. So it works. All right, let's try another one. Let's try one that looks a little different. We have a coefficient in front of our variable. It's not really any harder. Same method. Just another algebraic step. All right, so we have a quadratic. The way I know it's quadratic is because if I multiply, if I FOIL this out, then I'm going to get a 30n squared when I multiply the first two terms. So that makes it quadratic. That 2 makes it a quadratic right there. All right, we're not going to do that because that would be going backwards. We're trying to solve this. So the zero product property says if I set 5n minus 2 equal to 0, then the entire thing will be 0. If I set 6n minus 1 equal to 0, the entire thing will be 0. So algebraically, I solve this. So the same is true here. I add 2 to both sides, and I'll get these cancel. I'll get 5n is equal to positive 2. Then solving for n, I would divide both sides by 5. Remember, we have to undo everything. 5 over 5 is 1, so I'll get n is equal to, I'm going to leave it as a fraction because that is exact, 2/5. All right, we got to do the same thing for this other binomial, 6n minus 1 equals 0. Add 1. Those cancel, and I'm left with 6n equals 1. Then solving for n, I'll divide by 6. That gives me 1. I'll get n equals 1/6. Again, I'm going to leave it like that because that is exact. All right, let's try one that is not two binomials. Rather, it's still quadratic, but now I have a monomial and a binomial. I know it's still quadratic because if I were to multiply, if I were to distribute, that gives me 30p squared. And again, that 2 right there what makes it quadratic. So, still quadratic. All right, so we still use that zero product property. This is a term and this is a term. We set each one equal to 0. If 3p equals 0, the whole thing will be 0. If 10p plus 7 equals 0, the whole thing will be 0. Solving, notice that when I divide by 3, 0 divided by 3 is going to be 0. I'll get p is equal to 0 over here. And on this side, I'm going to go ahead and jump to the solution. I did 2 steps in one there. Hopefully you can follow them from the last problem. If p is negative 7/10, then my whole thing will be 0. All right, let's look at another one. How about y minus 8 squared equals 0? Well, there's two ways to look at this. We know that y minus 8 is really y minus 8, y minus 8, right? It's the same binomial squared. Well, if I set y minus 8 equal to 0 and y minus 8 equal to 0, notice it's the very same solution. That's totally fine. So if I add 8, I get y equals 8, and I get y equals 8. That's totally fine. It's called a repeated solution. And that happens. All right, so now let's actually factor some. So now we're going to combine what we learned in the beginning of the chapter, and we're going to use, so it's going to be an unfactored quadratic. So we've got to factor it first and then use the zero product property. So I'm going to, hopefully you remember from the last section how to factor this guy. When my a is 1, I just have to look at my c term, which is my negative 12. Two factors of negative 12 that will add together to give me the negative 1, which is my b here. So hopefully you can see that it's negative 4 and 3. Jumping straight into the factored form, when a is 1, I'm allowed to do that. I set each factor equal to 0. X minus 4 equals 0. X plus 3 equals 0. And then solve each one. X will be 4, and x will be negative 3. So combining what we did in the beginning of the chapter with the zero product property. All right, let's try one that looks a little different, one that is not in standard form. So let's say we've got 3c squared equals 10c minus 8. So this is still a quadratic, it's still an equation. I have an equal sign and I have an exponent of 2. However, it's not in the standard form. Standard form looks like this: ax squared plus bx plus c equals 0. Notice that we have all of our terms on the left-hand side in descending order, and it's equal to 0. So let's make this equation right here look like a similar formatting. So I need to bring everything to the left. I'm going to subtract 10c. Let me take that line off. And then I'm going to add 8 to bring them over to the left. That will leave me with 10c squared minus 10c plus 8 equals 0. So now this is a quadratic. Now this is a little bit harder one. Remember, when the a is not 1, this was, I want to say 7.3 that we were doing this. We had to multiply the a, which was 3, times the c, which is my 8, which will give me 24. Look for two factors of 24 that will give me the b term, which is negative 10. So we need them both to be negative in order to get the negative right here. So the factors of 24 are 12 and 2. Again, we have to both be negative. Then we could also have 3 and 8. Neither of these are giving us negative 10. We could have negative 6 and negative 4. I think those two will give me a negative 10 when I add them together. So remember, we're going to replace that middle term. So now the first one stays. The middle term becomes these two factors right here. If you use the box method, that's fine as well. This is how I teach the factoring when the a is not 1. So now I factor my first two terms. They both have 3c in common. That leaves me with c minus 2. Factor my next two terms. I'm going to factor out a negative 4. That leaves me with c minus 2. If my binomials match, we're using a method from, I want to say 7.1 or 7.2. So 3c minus 4 and c minus 2 are my two factors. So now I've got two binomials. So using that zero product property, I'm going to say if 3c minus 4 equals 0, everything is 0. If c minus 2 is 0, everything is 0. So solving these, I'm going to jump straight to that. I'm adding 4 and dividing by 3, and then adding 2. These are my two solutions. So notice that first of all, I had to get it into that standard form, is what I did here. Then I had to factor it by using the AC method, or the box method if that's what you prefer. Then I had to use the zero product property in order to solve my two solutions for this quadratic.